It's a great pleasure to be here and to join this great event and to be able to share what we're doing and how we are contributing to this great network, CIVICA. First of all, I'd like to start sharing my screen. Please confirm you can see my screen. Yep, great. So it's a great pleasure, and I'd like to talk a little bit about river basins and how they can be helpful in resolving some environmental crisis, or other way around, leading to more disasters, catastrophes, and things like droughts and water insecurities in the world or in Europe specifically. So I just wanted to actually start with this nice image as a background. All the images I will be using are not random, but they bring some feeling in what we're discussing. Here we have the border between China and Kazakhstan and two different patterns of development in the areas, and it's still one river basin presenting two different situations, two different ecosystems, how the resources are treated, and which one is sustainable path, sustainable development, we'll have to see. Specifically with your work maybe later. I just thanks Thomas for introducing me and covering what I do. And yes, I'm representing Central European University with a number of projects we're dealing here. I don't want to go to all of them. You covered them all. Number of things I could be talking about that, but I think the best would be if I just stay with this image, which I think represents very well what we're doing and what I'm doing, which is river basin with all the variety of natural, beautiful flows, river flows, and anthropogenic activities in the region. Plus, I think what is important here is different perspectives we can have on the same ecosystem, on the same data. Here you can see that river is green and vegetation is a bit brownish, let's say it this way, which is not really how we usually people see it. But if you process this data in remote sense data, you would be able to see it in a different way. So different perspectives really matters and really important. Just a little bit of trivial statement to start with. Rivers are a cradle of civilization indeed, and we know it for years, for centuries, for millennia. So let's put it this way, we know it's been like that. And of course, people living in those areas, civilizations, societies were transforming, converting those areas and making them more livable as they thought it would be and more adjusted to their own needs. And with time, indeed, it was developing more and more and more, and different communities, different societies were bringing their own perspective there. And from this regard, it would be very useful to think that whatever is happening within the rivers is defined by the so-called river basins, or by watersheds in which we operate and what we are functioning. And in brief, watershed and river basin is the area, land, catchment area, as a way, how it's called, contributing water to a river stream. And it's clear that whatever we do in this catchment area is reflected in the river, is reflected in water, and reflected in water security, causing sometimes flash floods, sometimes droughts. Downstream, upstream, doesn't matter. If we cut the forest upstream, we can have flood downstream. If we have too many dams upstream, we have droughts downstream. Well, maybe one of the biggest and largest and the most renowned example of such a catastrophe, such a problem was RLC disaster. For many years which was a symbol of such man-made or climate change disasters. It was perceived in different periods of time. But at the same time, it was drought. So drought was the synonym of RLC, as we know, is completely dried up. And it was a lot of deserted areas, and areas which were very productive harbor and famous for fishery became completely unused salty lands with a lot of corresponding problems in socioeconomic dimensions of society. But in the same time, if you just this we know. At the same time, the problem, the cause for this was very successful campaign against droughts upstream. The two river basins, Amu Darya and Sirdarya, and that was quite good actually, and very good for sustainable and economic growth in those areas. And it was actually cotton production primarily, but there were many others, irrigation channels. It was blossoming. Of course, during before, let's say, the collapse of Soviet Union, this area was treated and tried to be managed as one single unit, but later, with independent countries came into existence, every country was following their own interests and needs, and we have what we have. Basically, water was redistributed through this time, and we came into this problem of droughts downstream. And when we tried to, some of our students and what we were doing here at CEU, studying this process for quite a long time, let's say 10 years ago, 15 years ago, maybe, we were trying to study this process and see how water was redistributed. We had to download satellite imagery. It was long and very scrupulous process. We used 3 satellite images and a number of historic maps just to see how water was redistributed and how Aral Sea was shrinking and different lakes and water bodies upstream were growing up. It was the whole thesis for one of my students. Very good. And but it was proven that it wasn't really climate change, but just man-made catastrophe, anthropogenic factors. From this regard, later it became kind of, and for years we were trying to prove through our work that river basins is the most appropriate territorial unit for sustainable development. If this fragile balance is kept, then it might be sustainable development, and it's not considered to be kind of new statement or new idea, bright idea that was out there for a long time. I'm not sure if many of you are aware of this project or idea or initiative, which was launched by John Powell more than 100 years ago, who was suggesting that states in the United States of America now should be delineated based on watersheds, based on river basins, just to avoid potential conflicts between them in terms of water distribution, just to be able to manage the society and economic growth in a more sustainable way. Well, and we know it didn't really happen, but the idea is not new. And now Europe is trying to follow this approach, regardless of all those national administrative division, through a number of activities, through a number of projects, Water Framework Directive, different UN, Water Convention approaches we are contributing to as well. And it's going more or less certain way. But still, it's a quite complicated process, and we are facing a lot of problems, a lot of controversies. Sometimes people are talking about water wars, or a lot of tensions, transboundary, climate variations. Oops, apologies. In those areas, in river basins. Of course, it's very complicated to take so many factors into account, and in order to deal with those things, we have to use different tools. And what we do here at CEU, we are trying to use different environmental modeling techniques, such as basin modeling, river basin modeling. Here is one of the projects in Grids we were just dealing a number of years ago, where we tried to model the whole basin of Black Sea. And we were responsible for a number of smaller river basins. And basically, why is it good? Because you can put together many different factors and integrate them into one coherent model, and to see with that And those data sets can be coming from different sources, from different even organizations, sometimes from satellite imagery, sometimes from people, participatory, crowdsourced, citizen science, etc. Sometimes from national authorities. And then we used all this data for modeling, for doing forecasts according to different scenarios, which could be coming from, again, climate change variations or regional development plans. What is important that there is so much data out there which we can potentially use, and it's as I said, can be different. It can be physical, it can be environmental, it can be topography, it can be river streams, or socioeconomic factors, population density, agricultural activities, which is quite important. But what we have to remember all the time when we're trying to do this, that data is really geospatial, because we cannot, whatever we do now, we know this very well, that we send any tweet or SMS or walk around, everything is well recorded. Just think about when we are doing research in catchment area, in watershed, right? So whatever we are doing upstream have a lot of impact on downstream areas, and how, in which way it will have impact really depends on landscape, depends on the distance, depends on the conditions in the catchment area. For instance, if the forest area, as I was mentioning before, clear cut upstream, you should expect a lot of flash flood downstream. And if water kept in dams upstream, we will have droughts. That's happening nowadays worldwide. Let's say Central Asia, all those conflicts still talking about RLC between Kyrgyzstan and Uzbekistan, that one country wants water for producing the electricity generation, another one wants for irrigation, two different seasons, and they keep talking and trying to find some kind of consensus, which is quite hard to get. So spatial, geospatial components is crucial in whatever we do. And then we have a lot of data which is coming from in situ data, which is ground truth, ground collected data, Earth observations, going down in the field and doing measurements about water, or ex situ data, which is basically coming from above, from the distance. Usually, I like this image very much, and asking my students what it is, if they can imagine what that is. It's again, we don't have this luxury of doing it now, but you can just try to imagine what that is, and that is just green-blue algae, but in alternative false color. I don't know how many of you are familiar with remote sensing techniques, which also shows that a lot of data is out there, but it should be processed. We should use a little bit of different perspective to understand what it is. And as we know, there is ongoing real revolution in collecting, storing, and processing the data. And of course, it's a lot of data out there. This is Google data center with a lot of servers storing and collecting. Just imagine daily basis, weekly, monthly basis, all those satellites only going around the globe, and more and more of them collecting that information, trying to make it for our benefits, for better data-driven, evidence-based decision-making. But what we have to remember, that data itself is not information. In order to understand that data, you have to process it. And this is, I just decided to show you typical satellite image. That's how it looks. That's what is data stored in all those data centers. In order to understand, in order to see all those green-blue algae in pink color, you have to process it. And that's a lot of efforts and a lot of knowledge should be applied. And that's another example of what we were doing, and I like it very much. It's one of our projects on rural migration in Hungary, where we found and used exclusive data set on municipality level, low administrative unit division in Hungary, on a number of factors, trying to assess real, formal, informal, real, official migration by different regions. And it was about 3,500 different municipalities, regions. And when you're looking at it, you can be running as many tests as you wish and produce as many information as you wish, unless you try to map it geospatially and see make sense out of this data. And geospatial techniques, of course, is one, mapping this is one of the techniques how you can do that. And I really, that's why I'm coming back to the idea how important what we're doing here and how important that what organizers are trying to present here is to try to find those kind of ways to visualize the data and make it digestible for people and for decision makers and for policy makers and for academicians too. So there are different ways how you can treat it, data, how you can present it. But just to make a statement here, just by mapping it immediately, you can see that people in Hungary migrated from rural areas to some only few urban areas, and in case of Budapest, they were trying to go into suburbs and not to the city center. That's it. Just one map, few minutes, and information out there, instead of going through tables of 3,500 different units. Good. And going back to visualizing data on water security, and example of RLC, and my poor student who 10 years ago spent half a year writing this script. I don't know how many of you are aware of this very nice app and very nice website developed called Global Surface Water Watch. And nowadays, whatever we were doing back then is possible to do in a couple of clicks. There is a website, you go there, you go to the area of your interest, RLC in this case, this one lake in the middle here is called Idarku Lake, and by one click, one pixel, you can see when water appeared there. So once this area was filled. So as you can see here, there was no any water by year 1984, and from there it was permanent water. So this was done by actually one partner of our institution in Joint Research Center together with Google Earth Engine actually, and I will be talking a little bit about that in a few minutes, in a minute. By analyzing millions of different Landsat or satellite imagery, and a lot of computation power, supercomputers and Google Center, and it made available and online for everyone to use it. Unfortunately, it's badly underutilized still. It was about 5 years ago when they launched it, but it has global coverage. So whatever you're doing now, talking about water, talking about drought, you can even maybe, who knows, consider using it for your own purposes. Let's say in this case, it's one of the area we're studying Tiger-Euphrates river ecosystems, where the same problems of transboundary division and water insecurity are happening, and droughts. And we know that it's very bad situation, and even the war in the region, according to some studies, were caused by water insecurity. So all of them were based on Google Earth Engine, which we're using actively, which combines a lot of satellite imagery available online, different data sets uploaded by people. Sometimes you can upload your own, and planetary scale analysis capabilities supported by Google supercomputers. And you can do your own scripts and use it. If you don't use it yet, I highly recommend all of you exploring that. It's a great thing. There are many resources made available to researchers, to scientists, to even to policymakers based on this Google Earth Engine. That's another one, how we're trying to analyze situation in Tiger and Euphrates with a lot of different products available and satellite imageries and products based on it. Let's say Tiger here. Just note this link and try to use it later for your own interests. There are many, as I said. Many other data sources, Google Sentinel, not Google, sorry, Sentinel Hub playground. Again, real data, not near real time, but real time data. All the satellite images coming from, let's say, European Space Agency Copernicus missions are there. And you can, even without knowledge in remote sensing, you can just go to that website, and by clicking different buttons, no coding, no nothing, check different indicators, indexes, let's say moisture indexes in Europe or in other areas. Here I use an example of RLC again. For instance, here, that's moisture indicator in moisture index in the RLC basin. So to wrap up, we have a lot of information out there which is badly underutilized. Even this example of Global Surface Water Watch, the developer of it, Alan Belward, who was the head of acting director actually of Joint Research Center for a number of years and speaker at our professional training workshops in Budapest. So he was coming and trying to tell to all the researchers, just go and use it, because we made it available, but we don't have local context. We don't know what is happening in the global area, in the areas around the world. So you need to know local context to work with that. So it's badly underutilized. And all the data is there is badly underrepresented. So it's not only there, not studied, but it's also maybe some good findings which are just not shown. And I like this map as well, which is replicates the idea of here be dragons. And sometimes what decision making is the process is happening around the world and in Europe as well. Sometimes it reminds me of this here be dragons approach. People are trying to make decisions without really hard evidences, data-driven evidences, which are in reality are stored in those Google data centers or in other ones. So it's badly missing visualization for them and make it digestible for them. So that's why I salute the organizers of this event and hackathon, and salute all the participants, and wish all the luck in the work what you're going to be doing over those 3 days, and looking forward to all the great results you're going to produce. And finally, with the kind permission of the organizers, I want to mention how we are also contributing. We are part of CIVICA network, Central European University. We are trying to run similar events here. How to deal with all the data, specifically geospatial data through some universities specifically. It's already been launched for the next year, July 23, and we have a lot of speakers, not only ours, but our university and academic institutions, but also professional networks. Here I have a representative of Google, Alan Belward, whom I mentioned already from Joint Research Center, and our last year team of practitioners and students, well intermixed of them, at the last event. Thank you very much, and thank you for giving an opportunity to talk here. Thanks. Good luck.